Welcome dear students, we are in the CEC Gurukul lecture and we are discussing the errors in the management. We have discussed the many types of the errors, but presently we are discussing the random errors. Random errors occur due to the unknown sources during the measurement time, and that type of error is called the random error, and it is not possible to eliminate or minimize these errors, but if we want to get the accurate reading, then without any random error, then it is possible by the following steps. Number one step is take the more number of the readings by the different observers. Second, do the statistical analysis. And what are the statistical analysis? In which we do the mean, median, variation, variance, deviation, standard deviation, and that we will discuss one by one. How we take the mean, I think you all know about it, and it is very easy to take the mean. We are taking the multiple of readings. If we take the readings from x1 to xn readings, then for a particular measurement, the mean or the average value of these readings can be calculated by using the formula, like if you take the sum of this formula and divided by the n number of the readings. So m is equal to x1 x2 plus x3 plus xn divided by n, and m is the mean or the average value. This method we can get the accurate reading. If we take the mean of the reading, we take the multiple readings, and then we take the mean of that reading, then we can avoid the errors. If the number of the readings of a particular measurement are more, then the mean or the average value will be approximately equal to the true value. Next, we take the median. What is the median? If the number of the readings of the particular measurements are more, then it is difficult to calculate the mean or the average value. Then we calculate the median value, and it will be approximately equal to the mean value. So, for calculating the median value, first we have to arrange the reading of the particular measurement in an ascending order. Then we calculate the median value by using the formula, where just we have take the odd readings. You see here on the screen, this is the formula to get the median, that m is equal to xn plus 1 by 2. Then we calculate the median value by using the following formula, as is in the representing on the screen, that when the number of the readings in an even number, we take the odd number reading and the even number reading. By the above formula, we take the odd number reading, and then here is the even number of the reading, that is xn by 2 plus xn by 2 plus 1 divided by 2. Next is the deviation from the mean. We take the deviation from the mean. First we calculate the mean, the difference between the reading of the particular measurement and the mean value is called the deviation. Like in the short, we can say that deviation is, mathematically we represent di is equal to xi minus m. What is di? Di is the deviation of the ith reading from the mean, xi is the value of the ith reading, and m is the mean or the average value. So, in this manner we can find out the deviation. Next is the standard deviation, and these we are doing the statistical analysis. Now, next is the standard deviation. The root mean square of the deviation is called the standard deviation. Mathematically, we represent it as sigma is equal to root of d1, d2. Here, we take the different readings at the different values, and then we will take its standard deviation by taking the root and divided by the n number of the readings. So, by using this, we can get the accurate reading. The above formula is valid if the number of the reading n is greater than or equal to 20. When we are talking about when we are having a large number of the reading, repeatedly we are taking the reading just to get the accurate result. So, we can use the following formula for the standard deviation, then the number of the reading n is less than 20. So, if the number is less than 20, then we use this formula. This represented by d1, d2, d3, dn square divided by n minus 1, where sigma is the standard deviation. d1, d2, d3 are the deviation of the first, second, third and nth reading from the mean respectively. Now, if the value of the standard deviation is small, then there is a more accuracy in the reading value of the measurement. Next is the variance. Variance is the square of the standard deviation, and that is represented by V is equal to sigma square. V is the variance, sigma is the standard deviation. The mean square of deviation is called the variance. You see, it is represented by V is equal to d1 square plus d2 square d3 square plus dn divided by n, and this formula is valid when the n is greater or equal to the 20. When it is when we use it for the less than 20, then the formula is V is equal to d1 square plus d2 square d3 square dn divided by n minus 1. So, above formula for the value greater than or equal to the 20, and the below formula is for the reading less than or greater than 20. Where V is the variance, again d1, d2, d3 are the deviation or nth reading mean respectively, and with the help of statistical parameters we can analyze the readings of a particular measurement. In this way we will get the more accurate measurement value, and there is a least chances to occur the error, or we can just minimize the error. So, next is the errors in the measuring instrument. So, no measurement is free from the error in reality if we are working manually. An intelligent skill is taking measurement is the ability to understand result in terms of the possible errors. If the precision of the instrument is sufficient, no matter what is accuracy is, a difference will always be observed between the two measured results at the same time. So, an understanding and carefully evaluation of the error is necessary in measuring instrument. So, the accuracy of an instrument is measured in terms of error. So, what are the points? First, we take the true value. The true value of the quantity being measured is defined as the average of an infinite number of the measured value when the average deviation due to the various contributing factors tends to 0. So, no ideal situation is not possible. In ideal situation, it's not possible to determine the true value of the quantity by experimental way. Normally, an experimenter would never know that the quantity being measured by experimental way is true of the quantity or not. In practice, the true value would be determined by the standard method, and that method is agreed by the experts or the sufficient accurate values. Next type of error is the statistic. Statistic error is defines the difference between the measured value and the true value of the quantity being measured, and it is expressed by the del m is equal to am at minus at, measured value minus the error value, as already discussed. So, del A is also called the absolute statistic error of the quantity A, and it is expressed as summation naught del A, where summation naught is equal to the epsilon naught is equal to the absolute statistic error of the quantity A under the measurement. So, absolute value of del A does not specify exactly the accuracy of the measurement. So, the quantity that we are measuring is not accurate, but the quality of the measurement is provided by the relative statistic error. So, what is relative statistic error? So, this relative statistic error is defined as the ratio between the absolute static error and the true value. For First we calculate the absolute statistic errors, and that will be divided by the true value that quantity is measured. So it is expressed as, on the screen you are seeing that the summation epsilon r is equal to absolute error divided by true value, that is represented by del A by AT, and it is represented by some epsilon naught divided by AT. So percentage statistic error defined by, as we multiply by the 100. From the above equation we can find out AT is equal to AM minus del A, or AT is equal to AM minus epsilon naught. In this way, then we have the AT is equal to AM minus epsilon r AT. The final result we will get after solving it by taking the AT common, then AT is equal to AM by 1 plus epsilon r. So epsilon naught del A is small, which means that the difference between the measured value and the true value is very small, and AM minus AT is negligibly or very small. So we can eliminate it as AM is equal to AT. So when ER is less than 1. So the final result from the equation above, we can get AT is equal to AM into 1 minus epsilon r. So statistic error corrections, or the methods of the correction, it is the difference between the true value and the measured value of the quantity. So the above we can get this. So what is the source of error? The source of errors other than the inability measurement are: number 1, insufficient knowledge of the process parameters or design conditions. Number 2 is the poor design. Number 3 is the change in the process parameters, irregularities and the disturbances in the instrument. Sometimes poor maintenance produce the errors. Sometimes errors caused by people who operate the instrument or the equipment. Certain design limitations will produce the errors. What are the error intervals? It is the interval that defines the boundaries for the actual value to lie on. For example, if you consider the experiment that give the final reading like 10 ampere, if the precision of taken into the account by 2%, then it means the actual value lies between the 10 minus 0.2 or 10 plus 0.02, between the 9.98 or between the 10.02. So the estimation of the error interval gives the absolute error associated with the instrument. So how we evaluate the type A and type B evaluation of the uncertainty? Type A measurement takes into the account that the knowledge of an input quantity is taken only after considering the repeated measured value, and this process is called the type A evaluation of the uncertainty. How we evaluate the error or how we evaluate the uncertainty? Then in this case, first type is the measurement takes into the account that the knowledge of the input quantity is taken only after considering the repeated measurement of the value. And second, in this case we consider the repeated value for measurement in the input, and in other words we consider the Gaussian distribution. Thus there is an expectation which is equal to the average of the measured response value. So the standard deviation is equal to the average of all the standard deviation. Then we can get the type A uncertainty error evaluation. If we evaluate the uncertainty taking into the account only a few measured response values, and it can consider as a T distribution. On the other hand, if we talk about the type B measurement that takes into the account scientific judgment of the other information concerning the possible value of the quantity. Like if we are taking the type B evaluation of the uncertainty, so the information that is available to us is often the value that lies in the specified interval. So the concept of rectangular probability distribution with limits is used in this case. So that was the type A and type B type of evaluation of the uncertainty. Thus, what are the statistical methods of accessing measurement errors? There are the certain methods that are adopted to access measurement errors. First is the standard error of measurement, that is represented by SEM, and it tells about the deviation or the true values of how an instrument when used multiple times produce the desired result. That is the assessing of the error. Next is the coefficient of the variation. Like if the value on the repeated measurement how is defined, and if the CV means coefficient of the variation is low in the value, implies the results are closer to the true value, and it is defined as the how the values vary on repeated measurement. We will see that how much value is changing when we repeatedly getting the reading. So if the coefficient of variation is low in the value, implies the results are closer to the true value. Next is the limits of the agreements, that is defined by the LOA, and it gives the estimate of the interval where a proportion of the difference lies between the measurement. What are the ways to minimize the errors? There are the various ways when we are performing the experiment, we can minimize the errors. Number one is the use the instrument of the higher precision. Number two, improve the experimental techniques. Number three, which is most important, adjust the zero of the instruments correctly. Number third, take the values of the reading by standing straight to the instrument and not from the side to avoid the parallax errors. We should take the reading straight through to the experiment. Now next is the repeat the experiment several times. So we take the multiple readings so that we can take the average, and we can take it algebraic means for the closer result. Another important point which will be taking care to reduce the error is take care of the environment if possible. Take the measurement carefully in order to avoid the gross error, means do the less mistake, as that is the human error. Please try to do it in a minimum way. So the other type of errors, we will discuss the three main type of error, but apart from that we are having other type of errors also. There are the various type of errors that can be happen in a common day-to-day life. First is the absolute error. What is this? It is defined as the amount of error in the measurement. For example, if we have a sack whose actual weight is said to be 100 kg. Now suppose in the weighing machine the sack weighs out of the 150 kg, then there is a 50 kilogram error difference associated with the weighing machine, and this associated error of the machine is referred to an absolute error. Second is the greatest possible error, and it is the error which is defined to be 1/2 of the measuring unit. Next is the instrument error that we discussed, then it is the error that is associated with the instrument. This is simply the inaccuracy of the instrument. other is the operator error. The errors that are caused by the operator is called the operating error. And the experiment conducting in the lab, the man or the students are taking the notes of the voltmeter to the 5 volt where it is actually at the 4 volt. There is a position how you take the reading, and then the error caused by the measurement would be due to the man who observed the value. The such type of error is commonly referred to as an operator error, or that is also the personal errors. Next is the measurement location error. The errors that are caused by the instrument that is kept at the location in which it was not bound to be kept in, called the measurement location error. For example, if we take the case of the thermometer, then it is recommended to be kept away from the sun. Suppose the thermometer is placed within the reach of the sunlight, then after the value noted using that particular thermometer, the chances of the error to occur. Such cumulative errors are broadly classified under the various category, like parallax error, like external error. Parallax error, what is the parallax error? These errors happen due to the wrong sides of the measurement being taken. We also have seen the figure that how we taking the error, how we taking the reading through the instrument. Always take readings by standing straight in front of the instrument and not from the side, that in the case of the manual reading. Next is the external error, the errors that are caused due to the external factors like the wind, environment contribute to the external errors. Percentage error, the errors that is defined as a ratio of the difference between the actual value and the measured value to the actual value is called the percentage error. We calculate the percentage error with the actual value. Then how the measured value is getting the percentage error as compared to the actual value, that we will note in terms of the percentage error. Next is the relative error. It is defined as a ratio of the absolute error to the measured value. How we calculate the errors? So, the measurement errors calculation, how we will do. So, the calculation of the errors in the measurement system does not mean that the dimension is not correct. So, the device measurement is not accurate due to the apparatus. These errors are categorized into the 3 types, namely absolute error, relative error and the percentage error, if we take the error calculation. So, you see on the screen that this absolute error can be defined as the variation between the value of the actual and measured. That is a very simple type of error, variation in the actual value and the measured value, that VA minus VE. Second is the percentage error. We will take the percentage of that and then it is the percentage we will get. Third is the relative error. So, these 3 errors we should measure when we are performing the experiment in the laboratory. First, the absolute error, that is different from the actual value. Percentage of error, how much percentage we will get, percentage error we will get through the actual value. Third is the relative error, how the absolute error we will get through the actual value. So, here the measured value is just denoted by VA and the exact value is denoted by the VE. So, the measured example if we take, you see on the screen, we are taking the example like for the measurement error. First, a length was calculated to be 5.8 feet, but the absolute length was 5.72 feet. Now, how we calculate the errors for the absolute as well as the percentage? It is very easy. We will take the what is the actual value, that is the VA is equal to 5.8 feet, and what is VE, that is the absolute length is 5.72. 72, it's a 72. Then how we will get the difference between that, that is a 0.08 feet. So, percentage error, now we will calculate, that is a 1.4% error we will get in this reading. So, relative error is the 0.08 divided by 5.8, that is the actual length, calculated length. So this is the relative error. So through this we can get the absolute error, percentage error and the relative error. Now another problem is a resistor is marked in the laboratory with the specification of 100 ohms and 10% find the true value of the resistor. So how we calculate? The percentage error is given to be 10% and means the true value is the 100 plus 10%, that is, or the 100 minus 10%. So the 10% of 10 is equal to 10. So the values may be 90 ohm or the 110 ohm. That is another example we have taken, that an instrument having the specification of the 100 ohms and we are having error of the 10%. So if the 10%, then the value will be the 10. So the 10% of the 100 is equal to 10. Therefore, the value will be the 90 ohm or the 110 ohm from the actual value, that is the 100 ohm. So how to handle the errors in the instrument? As we discussed that how we handle the error, how we remove the, it is not possible to remove the errors, but we minimize the error. So how to handle the errors in the instrument? Use a higher precision instrument. Number 2, calibrate the instrument. This is very important to calibrate the instrument, means ensure the instrument is properly calibrated and adjusted. Third means take the repeated measurement, as we already done, and we are having the statistical parameter for this, for the repeating measurement like mean, median and standard deviation, adjusted variation, like that we can do the repeated measurement and take the multiple measurement of the same quantity to reduce the random error. Avoid external changes. What it does mean that changes in the external condition like temperature, pressure and humidity. Double check the measurement of recording and observation. Sometimes sometimes the multiple methods to measure the variation using the different instrument, and then we can get adjust it. Now if we take the, as we talk about the calibration, so calibration is the most important part to reduce the error. So if we calibrate the instrument, then we can avoid the errors. Then what is this instrument? Instrument basically a measuring device for determining the present condition of the observed parameter. So if we take the instrument, like if we take the example, it include the instrument include the pressure gauge, weight scale and spectroscopy meters. The scale of the instrument usually conform the international standard values. So how these instruments can be inline, build apart from the equipment, or the standalone instruments can have the single functionality. Sometimes it has a multiple functionality, or it work in the hybrid manner, hybrid multiple functionality, multiple ranges like oscillators, and sometimes the multiple functionality like multimeter. So how these instruments are calibrated and we can reduce from the error. So what is the instrumental calibration? Through calibration we can compare the reading of an instrument against the non-standard value of the measured under the specific condition and adjusting the controls of the instrument to improve the accuracy. So calibration plays a very important role in avoiding the errors during the experiment. So this calibration we will discuss in the next lecture. Thank you very much.